I welcome you all to this class. Please confirm me, am I audible to you and am I visible to you? Please confirm me so that it will be helpful for me. Please confirm, is my voice clear to you so that I can go ahead. Please make a comment in the comment box so that I definitely get to know about it. Please confirm. Please make a comment in the comment box so that I definitely get to know. Okay, fine. So thank you very much for confirming it. Everything is clear. Okay, so in this video lecture we'll be discussing about wave optics. Okay, so first of all, welcome you all to this class. Okay, for Karnataka CET 2021 and 2022. The present session is on wave optics. This is the lecture number 2 on the same chapter. We have discussed something good on wave optics yesterday. My name is Satish.T, lecturer in physics. I am an electronics and communication engineering. I have studied electronics and communication engineering. Okay, so this is my 7th year of experience in teaching physics for Karnataka CET and JEE Mains and NEET. Okay, I have 7 years experience for teaching physics even for board examinations. Okay, board examination kuda nanu 7 years teach ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Okay, this is my 4th month on Unacademy. Nowadays I am also a plus educator on Unacademy for Karnataka CET category. Okay, so thank you very much for listening to it and I welcome you all to this class. Okay, thank you. Before going to the discussion on wave optics, I would like to introduce you about Unacademy Plus subscription once. Okay, so you can clearly see about the Unacademy Plus subscription. Okay, and here are some of the best plans for Karnataka CET 2021 aspirants. ಯಾರ್ಯಾರು ಕರ್ನಾಟಕ CET 2021 ಬರೀತಾ ಇದ್ದೀರೋ ಅವರಿಗೆಲ್ಲರೂ ಕೂಡ ಒಂದು ಬೆಸ್ಟ್ ಪ್ಲಾನ್ ಕೊಟ್ಟಿದ್ದಾರೆ Unacademy-ಇಂದ. There's a 12 months plan at just rupees 12,375 and even there's a 6 months plan at just rupees 10,125 rupees. ಇದರ ಎರಡು ಪ್ಲಾನ್ ಇದೆ. And there's a 1 month plan at just rupees 2,250. ಇದು ಮೂರನೇ ಪ್ಲಾನ್ ನಿಮಗೆ. ಯಾಕಂದ್ರೆ this is another trial plan just for new subscribers. Okay, so I feel this plan is highly recommended for you. 12,375 rupees. ಇದು ತುಂಬಾ highly recommended plan for you people. Okay, so this is what actually about it. And if you use the code SATISHTLIVE, the e code if you use it, okay, you will get 10% off on the course fees. Again agutte 10% off sigute. So after 10% off, this is the price for you. Okay, e price okay, after 10% reduction. Okay, what are the advantages of the Unacademy Plus subscriptions are? Okay, so here the premium content at affordable price. Okay, this is the main important advantage. And you can clearly see the structured live courses plus dedicated doubt clearing sessions. This is the second important advantage by taking the Unacademy Plus subscription. Similarly, the quizzes at regular intervals for self-analysis and batches for complete preparation and test series for DPPs, full and mocks as well as analysis. Okay, so single subscription, unlimited access. Okay, if you take the subscription once you can access the any content of plus subscription. Aitha ಏನೇನೇ subscription ಮಾಡ ನೀವು ಅದನ್ನ ಏನು ಮಾಡಬಹುದು, you can definitely access the contents on Unacademy Plus subscription. Okay, so nowadays we are starting a Kannada batch 2.0 for Karnataka CET 2021 along with the core subjects physics, chemistry, mathematics and biology. Nanku kuda ide. So I am taking the entire physics over there. I am taking the entire physics over Kannada batch 2.0 for Karnataka CET 2021. Okay, so fine. So now let's continue our discussion on wave optics. Okay, so yesterday we discussed about the wave optics. Okay, if you have missed those lectures, please go through that and you definitely get to know about it. Okay, see the first question. Look at the first question for today's session. Okay, the Brewster angle for the glass air interface is 54.74 degree. If a ray of light going from air to glass strikes at an angle of incidence 45 degree, the angle of refraction. The question is then the angle of refraction is the question. ಅಲ್ವಾ ಏನು ಕಂಡುಹಿಡಿಬೇಕು ನಾವು angle of refraction ಅನ್ನು ಕಂಡುಹಿಡಿಯಬೇಕು. ಓಕೆ ನೋಡಿ ಇಲ್ಲೊಂದು ನಿಮ್ಮ ಕಾನ್ಸೆಪ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತೀನಿ. ದಟ್ ಇಸ್ ವಾಟ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಸಪೋಸ್ ಇಫ್ ಹಿಯರ್ ಇಸ್ ಅ ಮೀಡಿಯಂ, ಇಲ್ಲೊಂದು ಮೀಡಿಯಂ ಇದೆ ತಿಳ್ಕೊಳ್ಳಿ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಇಂಟರ್ಫೇಸ್. ಆಯ್ತಾ, ಇಲ್ಲೊಂದು ಮೀಡಿಯಂ 1 ಇದೆ. ದಿಸ್ ಇಸ್ ಮೀಡಿಯಂ 1 and this is what medium 2. This is what medium 2. Either this is the interface. This is the interface. This is the interface. ಇವಾಗ ಏನಾಗ್ತದೆ ಅಂದ್ರೆ suppose if a ray of light incident on the interface separating two media, and this is the incident ray of light, ಇಲ್ಲಿ ನೀವೇನು ಬರೀತೀರಿ ನಾರ್ಮಲ್ ಅನ್ನು ಬರೀತಿಲ್ವಾ. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಡ್ರಾ ದ ನಾರ್ಮಲ್ ಅಟ್ ಅ ಪಾಯಿಂಟ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್. ಎಲ್ಲಿ ಪಾಯಿಂಟ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಇದೆಯೋ ಅಲ್ಲಿ ನೀವು ನಾರ್ಮಲ್ ಅನ್ನು ಬರೀಬೇಕು. ದಿಸ್ ಇಸ್ ದ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಲೈನ್ ಅಟ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ ವಾಟ್, ಇಲ್ಲಿ ಏನು ಬರೀಬೇಕು. ಹಿಯರ್ ಯು ಹ್ಯಾವ್ ಟು ವಾಟ್ ಡ್ರಾ ದ ನಾರ್ಮಲ್. ಹಿಯರ್ ಯು ಹ್ಯಾವ್ ಟು ಡ್ರಾ ದ ನಾರ್ಮಲ್ ಲೈಕ್ ದಿಸ್. ಇದನ್ನು ನೀವು ನಾರ್ಮಲ್ ಡ್ರಾ ಮಾಡ್ತೀರಿ. ಓಕೆ, ಸೊ ನಾವು ದಿಸ್ ಶುಡ್ ಬಿ ದ ವಾಟ್ ಆಂಗಲ್ ಆಫ್ ದ ಇನ್ಸಿಡೆನ್ಸ್. ಏನಾಗಬೇಕು ಅಂತ ಶುಡ್ ರಿಫ್ರಾಕ್ಷನ್ ಆಸ್ ವೆಲ್ ಎಸ್, ಇಲ್ಲಿ ರಿಫ್ರಾಕ್ಷನ್ ಕೂಡ ಇರುತ್ತೆ, ಅದನ್ನೇ ಪಾರ್ಷಿಯಲ್ ರಿಫ್ರಾಕ್ಷನ್ ಕೂಡ ಇರುತ್ತೆ. ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಸೊ ನಾವು ಹಿಯರ್ ಐ ಕ್ಯಾನ್ ಟೇಕ್ ಏನನ್ನು ತಗೊಳ್ಬೋದು ಅಂತಂದ್ರೆ ಅಸ್ಯೂಮ್ ದಟ್ ಹಿಯರ್ ಈಸ್ ವಾಟ್, ದಿಸ್ ಇಸ್ ದ ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ತಗೋಣ. ದಿಸ್ ಇಸ್ ದ ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಇಸ್ ಆರ್ ಡ್ಯಾಶ್ ಅಂತ ತಗೋಣ. ಆಯ್ತಾ, ಇವಾಗ ಇಲ್ಲಿ ದಿಸ್ ಇಸ್ ದ ಮೆಥಡ್ ಆಫ್ ಪೊಲರೈಸೇಷನ್ ಬೈ ರಿಫ್ಲೆಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಆಯ್ತಾ, ರಿಫ್ಲೆಕ್ಷನ್. ಆಯ್ತಾ, ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಇಟ್ ವಾಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಅಬ್ಸರ್ವ್ ದಟ್, ಇದು ಪ್ರಾಕ್ಟಿಕಲ್ ಮಾಡಿ ನೋಡಿದ್ದಾರೆ. ಇದೇನು ರಿಫ್ಲೆಕ್ಟೆಡ್ ರೇ ಆಫ್ ಲೈಟ್ ಇರುತ್ತಲ್ಲ, ದಿಸ್ ರಿಫ್ಲೆಕ್ಟೆಡ್ ರೇ ಆಫ್ ಲೈಟ್ ಶುಡ್ ಆಸಿಲೇಟ್ ಇನ್ ದ ಸಿಂಗಲ್ ಡೈರೆಕ್ಷನ್. ಈಗ ನಾನೇನೇ ನೋಡಿ ಆಯ್ತು, ವೇವ್ ಜಿಸ್ ಟ್ರಾನ್ಸ್ವರ್ಸ್ ಇನ್ ನೇಚರ್ ಹ್ಯಾಸ್ ಟೂ ಕಂಪೋನೆಂಟ್ಸ್ ಇನ್ ಇಟ್ ಅಲ್ವಾ. ಎರಡು ಕಂಪೋನೆಂಟ್ ಇರುತ್ತೆ. ಒನ್ ಈಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕಂಪೋನೆಂಟ್ ಅಂಡ್ ಒನ್ ಮೋರ್ ಈಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕಂಪೋನೆಂಟ್. ಬೋತ್ ಆರ್ ವೈಬ್ರೇಟಿಂಗ್ ಇನ್ ದ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್. ಒಂದಕ್ಕೊಂದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ವೈಬ್ರೇಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಬಟ್ ಇಟ್ ವಾಸ್ ಕ್ಲಿಯರ್ಲಿ ಫೌಂಡ್ ದಟ್ the reflected ray of light from the interface in the reflected ಆಗಿರುವಂತ ray of light, ಈ ray of light it was vibrating in the single direction. So ಅದಕ್ಕೋಸ್ಕರ we can say that the reflected ray of light is called as this is called as polarized light ಅಂತ ಹೇಳ್ತಾರೆ. This is called as polarized wave. ಅದೇನಾಗಿರ್ಬೇಕು, polarized wave ಆಗಿರ್ಬೇಕು. ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಆಯ್ತಾ, ಸೊ ಅದು ಯಾವಾಗ ಸಾಧ್ಯತೆ ಅಂತಂದ್ರೆ when there is a what ಅಂತಂದ್ರೆ when there is the angle between incident ray of light and refracted ray of light makes a 90 degree. ಇದರ ನಡುವೆ ಎಷ್ಟಾಗಿರಬೇಕು, 90 ಡಿಗ್ರಿನೇ ಆಗಿರಬೇಕು ಅನ್ನೋ ಕಂಡೀಷನ್ ಇದೆ. ಸೊ ಆ ಟೈಮಲ್ಲಿ ಏನಂತ ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ at that time we will got an expression that is also called as Brewster's law ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ, or else polarizing law ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. ಆಯ್ತಾ, that says that refractive index of the medium that must be equal to tan theta p. Okay, so theta p is the angle of the incidence for which the angle of reflection is 90 degree and the ಏನಾಗಿರಬೇಕು, ಆ ಟೈಮಲ್ಲಿ ಏನಾಗಿರಬೇಕು, that must be what, sorry ನಾನು ಹೇಳಿದೆ ಅಂದ್ರೆ I am saying that this ray, the reflected ray has to make 90 degree with what, 90 degree with the refracted ray of light. There should be the angle between refracted ray of light as well as reflected ray of light, that must be 90 degree, so that the reflected ray will become completely polarized. ಅದೇನಾಗುತ್ತೆ, completely polarized ಆಗುತ್ತೆ. So this is how we can use the mu is equal to tan theta p. ನಾವು ಈ ತರ ಏನು ಮಾಡಬಹುದು, tan theta p ಅನ್ನು ಯೂಸ್ ಮಾಡಬಹುದು. ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತೀನಿ, do not get confused. Okay, do not get confused. Okay, ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ if there is a incident ray of light, ಅದು ಬಂದ್ಬಿಟ್ಟು ಒಂದು ಇಂಟರ್ಫೇಸ್ ಮೇಲೆ ಬಿದ್ದರೆ, ಓಕೆ, if it is parts in the interface separating the two media, ಆ ಟೈಮಲ್ಲಿ the partial refraction and partial reflection ಎರಡು ಕೂಡ ಆಗುತ್ತೆ. ಓಕೆ, there should be a partial reflection as well as partial refraction. Okay, but there should be the angle of how much, 90 degree in between reflected ray of light as well as refracted ray of light. Okay, in between them there should be a 90 degree. So but it is clear that the angle of incidence for which the reflected ray of light and the refracted ray of light, both reflected ray of light and refracted ray of light both makes 90 degree one to another. At that time we say that the reflected ray of light is completely polarized. Okay, the reflected ray is completely polarized. That should be completely polarized. Okay, that is what very very important concept for you. So okay, so now we can use mu is equal to tan theta p. Mu is equal to tan theta p. We can use this expression. Okay, very very important. Theta p is called as polarizing angle. Theta p is called as polarizing angle or as Brewster's angle. It is also called as Brewster's angle. Polarizing angle. It is also called as Brewster's angle. It is also called as Brewster's angle. Is it clear to everyone? So theta p is the angle of the incidence for which the refracted ray of light and reflected ray of light makes 90 degree in between, and the reflected ray of light is completely polarized. That is called as polarizing angle. I hope that is clear to everyone. Now we shall solve this problem. Okay, we should solve this problem now. Now if you look at this problem statement, What is the given information? The Brewster angle for the glass air interface is 54.74 degree. Okay, it's clearly given that theta p is equal to 54.74 degrees, clearly given. Okay, and the question is to find out the value for what? If a ray of light going from air to glass, okay, the ray of light is going from air to glass, strikes at an angle of incidence of 45 degree. Okay, angle of incidence is 45 degree. Then the angle of refraction is, okay, angle of refraction is the question. You need to find out the value for r dash is equal to how much? Okay, as you know that mu is equal to tan theta p. Correct? Suppose if I substitute the value for theta p, I will get tan of 54.74 degree. Correct? They have clearly given that tan of 54.74 degree is equal to root 2. So I got a value for mu as root 2. Okay. So now the ray of light is traveling from air to glass. The ray of light is traveling from air to glass. There should be refraction of the air to glass medium. So that's the reason why let me apply the Snell's law. Snell's law at the first surface. ಈ ಸರ್ಫೇಸ್ ನಾವೇನು ಮಾಡೋಣ, ಸ್ನೆಲ್ಸ್ ಲಾನ ಅಪ್ಲೈ ಮಾಡೋಣ. ಸ್ನೆಲ್ಸ್ ಲಾನ ಅಪ್ಲೈ ಮಾಡಿ. Okay, we shall apply the Snell's law for this interface. So for that, what I can say is sine of angle of incidence to the sine of angle of refraction, that must be equal to refractive index of the glass with respect to refractive index of the air I can take. Okay, so therefore sine of angle of incidence is sine 45 degree. That will be equal to sine 45 degree divided by sine of angle of refraction is sine r. That must be equal to refractive index of the glass. Okay, refractive index of the glass is how much now? They have given it as root 2 now. This is what the refractive index of the medium. That's what we have calculated. Root 2 divided by 1 I can take. So now by using the trigonometric relationships, I can say that sine r must be equal to, okay, sine r equal to, this is what, how much? Sine 45 degree is 1 by root 2, and there should be the cross multiplication, it should be 1 divided by root 2. So that is equal to 1 by 2. It implies r must be equal to how much? 30 degree. R must be equal to 30 degree. So this is how we can solve this problem. Either now we problem solve ಮಾಡ್ಬೋದು. Okay, r equal to 30 degree, and this is the right answer for this question. This is the angle of refraction. Sine of angle of refraction is 30 degree. So which option is correct? Option B should be the right answer for this problem. Okay, option B. Option B is the right answer. 30 degree is the right answer for this question. Okay, I hope it is clear to everyone. Okay, those who are looking for Unacademy Plus subscriptions, where you will definitely take the structured live courses. Okay, you can use my code SATISHTLIVE. Okay, and you will definitely get 10% off on the course fees. Okay, so Unacademy Plus subscription as well as 10 SATISHTLIVE, use this code and definitely get 10% off on the course fees. This is the benefits by using my code. Okay, fine. Is it clear to everyone? I hope that it's clear to everyone. We shall move to the next problem now. Okay, we should go to the next problem. Look at this problem. Unpolarized light falls first on polarizer, okay, then on the analyzer. If the intensity of the transparent light from the analyzer is 1 by 8 of the incident unpolarized light, what will be the angle between, this is the path axis, okay, not the topic axis, path axis of polarizer and analyzer is the question. Okay, this is a beautiful problem. Let me try to answer this problem. Okay, let's try to answer this problem. But first of all, let me draw the pre-polarized diagram for this question, ray diagram for this question. Okay, so here is a polarizer. Okay, so this is a polarizer, polarizer P, and this is for analyzer. This is what? Analyzer. Okay, analyzer A. Okay, polarizer is used to make the polarization, and analyzer is used to check whether the incident ray of light is plane polarized or not. So this is the two conditions you need to use here. Okay, the first of all, let me say there is some incoming ray of light which has the intensity I. Okay, let me take I is the intensity of incoming light. Okay, I is the intensity of incoming light. Okay, incoming light. The consideration ಮಾಡೋಣ. Okay, it falls first on what? It falls first on the polarizer. Polarizer line ಬೀಳುತ್ತೆ first ಗೆ. Okay, so it is given that if the intensity of the transparent light from the analyzer is, analyzer ಇಲ್ಲಿಂದ ಹೋಗ್ತಾ ಇರೋದು, analyzer ಇಂದ ಹೋಗ್ತಿರೋದು 1 by 8 times what? the incident unpolarized light, that is what I 1 by 8 times I ಅಂತ ಅವರೇ ಕ್ಲಿಯರ್ ಆಗಿ ಕೊಟ್ಟಿದ್ದಾರೆ. The question is to find the value of a path axis between those two. Polarizer ಮತ್ತೆ analyzer ನಡುವೆ what is the value of theta ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. Okay, let me take, so this is the I dash ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. I dash is the final emergent intensity of the light. Okay, ಇವಾಗ ನಾನು ಅಂತ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೇನೆ, ಇವಾಗ assume that here I naught is the intensity of the light passing from the polarizer. ಇಲ್ಲಿಂದ I naught ಹೊರಗಡೆ ಹೋಗ್ತದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. Okay, so I clearly told you that intensity of the light emerging out of the polarizer must be equal to ಏನಾಗಿರಬೇಕು I divided by 2. Exactly it reduces by 2 because ಯಾಕೆ reduce ಆಗುತ್ತೆ, either any one of the components, either electric field or magnetic field component, any one of those two components can be removed, eliminated by the what, path axis of the polarizer. So nage other one the component remove ಮಾಡುತ್ತೆ. So ಅದಕ್ಕೋಸ್ಕರ intensity has to be decreased by 2. Okay, so ಅದಕ್ಕೋಸ್ಕರ I naught equal to how much, it should be I naught by 2 ಅಂತ ಆಗುತ್ತೆ. So now this is the I dash. Now I naught is the intensity of the light falling on or else coming to the what, analyzer ಬರ್ತಿರೋ intensity ಎಷ್ಟು I naught ಆಗಿರುತ್ತೆ. So ಅದಕ್ಕೋಸ್ಕರ I dash is the intensity of the emergent light from the analyzer. Okay, so therefore I can take the equation that I dash must be equal to I naught cos square theta. This is the condition. This is what we have discussed yesterday. Now this ಬಗ್ಗೆ discuss ಮಾಡಿ ಆಗಿತ್ತು. The intensity of the light emerging from the analyzer must be equal to I naught cos square theta. Okay, so therefore we can say that the value of I naught is I by 2. I by 2 cos square theta I can take. This is the value for I dash. Okay, this is the condition that you take. Now it's clearly given that I dash equal to 1 by 8th of I ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. Okay, so I dash equal to 1 by 8th of I is given properly. This is the condition given in the question itself. So let me apply that now. Okay, it should be equal to 1 by 8 times I, that is equal to I by 2 into what, cos square theta. So now by I cancelled, this is what, 2 ones are 2 4s are left with what, 1 by 4 equal to cos square theta, equal to cos square theta. It implies cos theta is equal to 1 by root 4, that is equal to 2. Okay, so for what value of theta, cos theta, the value is 1 by 2. Can you please tell me? The value of theta must be equal to how much? 60 degree. Okay, as you know that cos 60 is 1 by 2. Cos 60 is 1 by 2. So that's the reason why the theta value must be equal to 60 degree. So that's the reason why we have found out the value for that, and the answer is 60 degree. 60 degree is the right answer for this question. Option D is the right answer. Clear? So this is the path axis between two polarites, that is one is polarizer as well as analyzer. So we can answer such other questions like this. This is a very good problem, one of the appeared CET problem. So this is how we can expect the problem on Karnataka CET. Okay, so one request for you is that we are solving a lot of problems on Unacademy platform. Please do download Unacademy application, learning application from the Google Play Store, and just put your mobile number and essential information on that, and just log in into it, and definitely access the lectures for free of cost first. Okay, if you are very comfortable with that, and definitely show that you will be definitely comfortable with that, and you will definitely get very good courses as well. Okay, join into Unacademy Plus subscription by using the code SATISHTLIVE. Okay, and definitely get 10% off on the course. Okay, so these are the advantages by taking Unacademy Plus subscription. Okay, fine. We shall go to the next problem now. I should move to the next problem. Okay, here you can see the next problem. This is the problem on Young's double slit experiment, because we can explore the problems on Young's double slit experiment as well. Okay, the problem says that in Young's double slit experiment, the slits are 2 mm apart and are illuminated by photons of two wavelengths, lambda 1 equal to 12,000 angstrom and lambda 2 equal to 10,000 angstrom. At what minimum distance from the common central bright fringe on the screen 2 meter away from the slits, okay, will a bright fringe coincide? Okay, where bright fringe from one interference pattern coincide with a bright fringe of the other. This is a very good problem. ಯಾವಾಗ coincidence problem ಬರುತ್ತಲ್ಲ ಆ ಟೈಮಲ್ಲಿ uses expression n1 lambda 1 must be equal to n2 lambda 2. Okay, uses equation to get the value for that equal to n2 into lambda 2. Okay, this is the condition you need to use first of all. Okay, so it is clearly given that coincidence. If you find out the word coincide or coincidence, you must use this expression. ಈ expression use ಮಾಡಲೇಬೇಕು. Okay, n1 lambda 1 equal to n2 lambda 2. Okay, if you use so, you definitely get the value for n1 and as well as n2 you get. So that is equal to lambda 2 divided by lambda 1. So lambda 2 is given as how much? It is given as 10,000 angstrom divided by 12,000 angstrom. This is equal to 12,000 angstrom. So that how much you get here? You get 5 divided by 6. So now you got the value for n1 by n2. n1 by n2, that must be equal to 5 by 6. So I can say that n1 equal to 5 and n2 is equal to 6 na position ಮಾಡಬಹುದು. This is what very important. Okay, now you got the value for n1 as well as n2 now. So now it's required to calculate the value of the distance from the central bright fringe, right? So now I can take like this. ಹೆಂಗೆ ತಗೊಳ್ಳಬಹುದು ಅಂತಂದ್ರೆ xn, distance of the nth bright fringe must be is equal to n into what? ಏನಂತ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡಿದ್ವಿ ನೀವು? n into what? You have read that beta is equal to lambda d divided by d. This is the formula you need to remember. Okay, so n times lambda d divided by d. This is the formula you need to use for the bright fringe, which will give you the distance of the nth bright fringe from the common central bright fringe. Okay, so now let me use the value of 5 here. 5 into lambda. Now I am using the lambda n1 use ಮಾಡಿದ್ರೆ ಏನು ಯೂಸ್ ಮಾಡಬೇಕು? lambda 1 ಯೂಸ್ ಮಾಡಬೇಕು. So value of lambda 1 is 12,000. Okay, 12,000 angstrom. 12,000 angstrom into 10 to the power of minus 10 into d. D is the distance between what? Slit and screen. The screen is 2 meter here. 2 meter ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. 2 meter divided by d. D is 2 millimeter. 2 into 10 to the power of minus 3. So now 2 gone. What we left with? Finally left with? We left with 6, right? 12 60 0 0 0. Okay, into 10 to the power of minus 7. Left with 10 to the power of minus 7. So that how much you will get here? Illon 0 ಎಂದು ತಿಳ್ಕೊಳ್ಳಿ. 1 2. Okay, ಇದರಲ್ಲಿ 1 2 3 4 5. Okay, or else you can write as 6 ಅಂತ ತಗೊಳ್ಳೋಣ into 10 to the power of how much? 10 to the power of 3 ಉಳಿತಲ್ವಾ? 3 ಉಳಿತು. Left with minus 3 ಅಂತ ಉಳಿತೆ. That is also equal to 6 millimeter. Okay, that is equal to 6 millimeter. Okay, definitely get 6 millimeter. This is what very important type problem. This is for a bright fringe. Okay, this is for bright fringe. So of course you can go for option C as the right answer. Very important type problem. So that you can definitely solve this one within 30 seconds. 30 seconds is the word and hard to problem. Okay, so I feel it's clear to everyone. Another very good type problem. Another repeated type problem on Karnataka CET. Okay, look at the next problem here. Two slits are separated by a distance of 0.5 millimeter and illuminated with a light of lambda equal to 6,000 angstrom. If the screen is placed 2.5 meter from the slits, the distance of the third bright fringe. Then expect the value of third bright fringe. Okay, third bright fringe na keltidare. Bright fringe. Third bright fringe. Okay, so therefore I can say that x3. Okay, x3 must be is equal to n times lambda d divided by d. This is the formula you need to use here. This is why I am using n equal to 3 into lambda. Lambda is how much? 6,000 angstrom. 6,000 angstrom into 10 to the power of minus 10 into how much? Into d. Capital D is how much? If the screen is placed 2.5 meter away from the slits. Okay, this is 2.5 meter away from the slits divided by d. The small d is how much? 0.5 millimeter. 0.5 milli. 10 to the power of minus 3 here. Okay, this is equal to how much? Can you please tell me? It should be 0.5. 5 ones are 5 5s. It will become 5. So answer should start with 9. The answer should start with 9. So because you can go for option D. You might not definitely get 9 only. Okay, but 5 ones are 5 5s. So that how much you get here? 5 30 90. Okay, 90 1 0 2 0 3 0. There are 3 different zeros are there. Into 10 to the power of minus 7 you get, right? Get 10 to the power of minus 7. This is indicated by how much? 1 2 3. Now correct? So 9.0 in 10 to the power of minus 3 meter. This is what 9 millimeter. So we can go for option B as the right answer for this question. This is how we can solve this problem. Is it clear to everyone? I hope that it is clear to everyone. This is how we can solve this problem. Okay. We shall take one more problem. Let's do it. Okay. In Young's diversity experiment in YDSE, the slit separation is 1 millimeter and the screen is 1 meter away from the slit. For the monochromatic light of wavelength 500 nanometer, the distance of the third minima is, okay, the third minima is equivalent to what? Third minima is equivalent to third dark fringe. Okay, third dark fringe. Bright to dark fringe. They respect the distance of third dark fringe from the center maximum. Okay, we have said that the distance of the nth dark fringe must be is equal to 2n minus 1 into lambda d divided by 2d. 2n minus 1 into lambda d divided by 2d. Okay, so substitute the value for n as 3 now. 2 into 3 is 6 minus 1 is 5 into lambda. Lambda is 500 nano 10 to the power of minus 9 into d. D is how much? Capital D is distance of the screen and slit is 1 meter divided by 2 into slit separation. The slit separation is 1 millimeter. Slit separation 1 millimeter. 1 into 10 to the power of minus 3. So that is equal to, now how much here? 12.4. The answer starts with 12.5. Okay, 12.5 start. So I can clearly go for option B as right answer. No need to check it again. I can note 25 divided by 2 into 500 10 to the power of minus 7 minus 7 minus 3 minus 4 10 to the power of minus 4. That is 10 to the power of minus 4. Of course, it should be how much? 12.5 into 10 to the power of minus 4 that is equal to 1.25 into 10 to the power of minus 3 meter. So it is equivalent to 1.25 millimeter. You can go for 1.25 millimeter. So that's the reason why you can go for option B as the right answer for this question. Okay, so this is how you can answer this problem. Okay, please download Unacademy learning application from the Google Play Store and log into it. You will definitely find a lot of lecturers on Karnataka CET category, on physics, chemistry, mathematics, as well as on biology. Okay, so on Unacademy platform we will definitely discuss a lot of the problems on optics, ray optics, as well as wave optics. Okay, so please take Unacademy Plus subscription by using the code SATISHTLIVE and you will definitely get 10% off on the course fees. Okay, there are a lot of advantages by taking the Plus subscription. There is a there are what? The structured live courses will be there. A lot of advantages. You can definitely find those structured live classes and all on the what? Unacademy Plus subscription. Okay, so nowadays we have started the Kannada batch. Okay, Kannada batch and start ಮಾಡಿದೀವಿ very soon. 11th in the start ಆಗಿದೆ. Okay, so we are still in the beginning. So you can join the Kannada batch 2.0 for Karnataka CET 2021 as soon as possible. Okay, so there I am taking the entire physics for you. Then only entire physics ತಗೊಳ್ತಿದ್ದೀನಿ. Okay, it is definitely beneficial for you, no doubt about it. ನಿಮಗೆ ತುಂಬಾ ಹೆಲ್ಪ್ಫುಲ್ ಆಗುತ್ತದೆ ಹೇಗೆಂದ್ರೆ. Okay, I request you, all of you, to get into Unacademy Plus subscription. Okay, by using the code SATISHTLIVE. You can clearly see my code here. SATISHTLIVE is my code to unlock the courses and all. Okay, so thank you very much for listening to this video and watching this video as well as listening to my classes, and I expect your cooperation in the preparation of Karnataka CET examination and all. Okay, so do prepare well for examination and be regular to the classes and all. That will definitely help you to score well in your examinations. Okay, so thank you very much. Please do like this video. Please do share this video with your friends and colleagues to support us. Please do subscribe to our channel Unacademy under Karnataka CET category so that you definitely get the notifications